Okay, let's analyze the 5 linear equations in projectile motion along the x-axis for constant velocity. So this would be v naught x. Since initial velocity in the x direction is constant, there is no acceleration. So acceleration in all 5 of the linear equations will be equal to 0. So we start off with the first linear equation. Vf is equal to vi plus at. If the acceleration is equal to 0, this term disappears, and you get Vf is equal to Vi. So final velocity is equal to initial velocity. That just sort of reaffirms that you're traveling at a constant speed throughout the entire parabolic trip. The second equation, distance is equal to 1/2 Vf plus Vi times time. It doesn't have an acceleration in it, so you can't put 0 for anything. But if Vf is equal to Vi, you add them together and that's 2V. So this would be 1/2 times 2V times time, which would be equal to 1/2 times 2 is 1 Vt. So you get distance equals velocity times time in the second equation. Now, if you recall, this equation is derived graphically, and the slope of the velocity time graph is acceleration. So acceleration is in this equation, but it's kind of hidden. Looking at the third equation, distance equals Vit plus 1/2 At squared. Now, acceleration again is 0, and you're left with distance equals Vit, and that becomes Vit. This zeroes out. And so your final equation for the third linear equation is distance equals velocity times time. Again, this is the constant velocity equation. And the fourth equation, distance equals Vft minus 1/2 At squared. Acceleration is 0, traveling at a constant velocity. So you end up with distance is equal to Vft. And the last equation is Vf squared is equal to Vi squared plus 2Ad. Acceleration is 0, that zeroes out, and you are left with Vf squared is equal to Vi squared. If you wanted to take that one step further, you can take the square root of both sides, and you end up with Vf is equal to Vi. Equation 5 and equation 1 give you that Vf is equal to Vi. The other 3 equations kind of break down and give you d equals Vt. Now, this is assuming a velocity in the x direction, and we proved just a little while ago that the cosine of theta is equal to V naught x divided by V naught. So V naught x is equal to V naught cosine theta. If you plug in the initial velocity of the x direction as the velocity constant over the course of the parabolic path, that's equal to V naught cosine theta. D is equal to Vxt for velocity in the x direction, and that's V naught x is the same thing as Vx. So your distance that you're going to travel in the x direction for parabolic motion would be V naught cosine theta t. And that's your final equation for constant velocity in projectile motion on the x-axis.